Hello, welcome to Physics 101 with Kevin Gomez and Robert Lazarin. In today's episode, we will cover the history of gravity.
It all started back around in 330 years before Christ with the Greek philosopher Aristotle. Aristotle argued that objects with more mass would fall toward the ground faster and their speed would increase as they got closer to Earth. For example, as shown in our video, Aristotle thought that the basketball would hit the floor first and faster than the golf ball.
Then physicist, philosopher, mathematician, engineer, and astronomer Galileo Galilei conducted the Tower of Pisa experiment back in 1589. In this experiment, Galileo Galilei demonstrated that the time of descent of objects is independent of their mass. As shown in the video, Galileo Galilei dropped two objects at the same time, and the result of those two objects was hitting the floor at the same time. This experiment then proved wrong Aristotle's argument.
Things got really serious when physicist, philosopher, mathematician, and astronomer Sir Isaac Newton came up with Newton's law of universal gravitation in the year of 1687. Originally, Sir Isaac Newton argued that the orbit of the moon depended on the same type of force that causes an apple to fall on Earth. Newton's law of universal gravitation states that every mass attracts every other mass in the universe, and the gravitational force between two bodies is proportional to the product of their masses and inversely proportional to the square of the distance between them. Today, we calculate force using Isaac Newton's second law of motion, which is force is equal to mass times acceleration. The acceleration of gravity is 9.81 meters per second squared. Today, gravitational force is calculated by the gravitational constant times mass 1 times mass 2 divided by the radius between them squared.
Later on in 1916, physicist, mathematician, and engineer Albert Einstein published one of the towering achievements of the 20th century physics. This theory explains that what we perceive as the force of gravity in fact arises from the curvature of space and time. Einstein proposed that the objects such as the sun and the earth change the curvature of space and time. Einstein was also able to calculate that the deflection of light rays predicted by his theory would be twice the Newtonian value.
Sir Arthur Eddington was an astrophysicist from Trinity College in Cambridge and the University of Manchester. In 1919, he conducted two expeditions to observe a solar eclipse to make his first empirical test of Einstein's theory. Einstein's theory included the measurement of the deflection of light by the sun's gravitational field. He proved that light in fact did deflect around the moon Using this newfound information, Eddington furthered Einstein's theory of relativity, but did not perfect it as there was another small margin of error.
It wasn't until 1960 that the general relativity theory gained further momentum. This momentum was due to the discovery of galaxies maintained by an enormous pool of black holes in the center. Gravity is responsible for the pool created by black holes. Black holes exhibit such a strong gravitational effect that nothing, not even a particle, and/or electromagnetic radiation such as light, can escape from inside.
Quantum gravity is all theoretical physics that is trying to describe what gravity actually is in reference to quantum mechanics. Since it is with respect to quantum mechanics, quantum effects cannot be ignored when coming up with a theory. A graviton is considered an elementary particle in physics. Since the existence of such things to be proven, a graviton is a branch of theoretical science. Gravitons are thought to be the particle that mediates the force of gravity in the entire framework of quantum field theory. If such particle does exist, it is expected to be massless. The Higgs boson is an elementary particle in the standard model of particle physics. It is a quantum excitation of the Higgs field, a fundamental field of crucial importance to particle physics theory. First suspected to exist in the 1960s, unlike other known fields such as the electromagnetic field, it is a non-zero constant value in the vacuum.
So is gravity real or just an illusion? Thank you for watching.